So we're continuing on with angular acceleration, first discussing what linear acceleration is. So if you can write that down, and linear acceleration. We're going to come back and put a little subscript here later, but this is going to be equal to the change in velocity over the change in time. This is the formula that we all know. So we're going to look at the analogous formula as we did for velocity, as well as we did this for the angular displacement. So my alpha is going to be similar to not the change in linear velocity, but it's going to be the change in angular velocity. Okay, that's going to be the formula for the delta. What's the change of angular velocity? Omega over the change in time. So here is a master formula, and the units of this, as acceleration is meters per second squared, this is going to be measured in the radians per second squared. Again, what this means is we're looking at a spinning object. We're seeing how quickly our spinning rate is changing, whether it's increasing or if it's getting slower. Okay, that's what we're going to be looking at for these types of problems. So we have our formula for regular acceleration. So acceleration is going to be equal to the change in velocity over the change in time. And we have our formula from previous section, which is that the velocity is going to be equal to r times delta omega. So we can plug this in to right here. What's my velocity? My velocity is dependent upon how quickly it's spinning times the radius. Again, this is linear velocity. So when we plug this in, we get acceleration is equal to r times delta omega. Okay, and then we have the denominator. This is going to be delta t. But if you look at this, we have delta omega over delta t is this formula for acceleration. So very similarly, my acceleration will be equal to r times alpha. My linear acceleration will be dependent upon the rate at which the spinning is changing times the radius that you're at. Okay, so imagine that you have a wheel. So here's your wheel, and it's on a car, and here is the road. Okay, so here's your wheel. We have a couple different accelerations, so I want to kind of review this. We are going to be having a centripetal acceleration. Okay, if you remember that we have a spinning object, the acceleration is going to be toward the center. And if we are speeding up like this, okay, we have also an angular acceleration, but we will also have what's called the linear acceleration. So that's what we're trying to calculate right here. So if we're going forward, this wheel is actually going to be spinning in this direction. Okay, so we have a spinning direction like this, and so my linear acceleration will be looking like this. It's going to be A, and it's going to be forming a perpendicular to this centripetal acceleration, and this is going to be called my tangential acceleration. Tangential acceleration actually is just another name for the linear acceleration, as it occurs at a tangent from the circle. So my tangential acceleration is just another name for linear acceleration, and it is tangential. So it's tangential to a point on the circle, which is right there. Okay, so imagine that we have this formula. We can go ahead and, since this is the linear acceleration, we can say also that this is the tangential, or the tangential. Okay, we can also say that is the tangential acceleration. So looking at this formula right here, if we increase the angular acceleration, what's going to happen? This means my spinning rate is changing, either increasing or decreasing. So now we're increasing. If I'm increasing my acceleration, it means that my spinning rate's getting faster. Well, if you look at the formula and you plug this in here, you're going to be increasing your acceleration. So you increase your acceleration, meaning that the wheel is going to go faster. If we have a larger wheel, if we increase the radius and keep the acceleration the same, that will also increase my tangential or my linear acceleration. So it'll increase my acceleration. It will go faster. As does if you're looking at the formula for V is equal to R times W, or the delta, the change in omega. If I increase my R here as well, if I increase my R, that's going to increase my velocity. I'm going to be going faster.